Hi. So today we will learn Vernier Callipers. Vernier Callipers is a device for measurement of length, and it measures length with greater accuracy than what your meter scale measures. So let me take one of the Vernier Callipers. Here is, you can see in diagram, a Vernier Callipers. This is your Vernier Callipers. It has metallic body and it has two lower jaws, large lower jaw you can see. Here is one jaw, jaw 1. It is another jaw, jaw 2. This is movable jaw. So it is called sliding calipers. You have two jaws in upper direction 2. This is jaw 3 and this is your jaw 4. Now, for measuring the internal diameter of any pipe, we put the pipe inside the two upper jaws and we can find the internal diameter of any pipe. Now in lower jaws, we put the thing inside. Suppose we have to find the outer diameter of pipe, we put the whole pipe in between the two jaws. This jaw is sliding jaw. And we have two scales. The scale on sliding part is called Vernier scale. The scale on sliding part is called Vernier scale, and the scale on main body. You can see here you have a meter scale on the main body. Here 0 is there, 1 is there. So you have a scale on main body, and you have another scale on the sliding part, that is called Vernier scale. So you have one main scale and you have one Vernier scale. And here one stripe comes out. This stripe is used to measure the depth of any bottle. When you put this stripe inside any bottle, keeping this Vernier scale outside, then you can measure the thickness of, then you can measure the depth of this bottle. So a Vernier scale can be used to measure internal diameter. Here you can see it towards lower jaw. Using upper jaw, you can find internal diameter, okay, and using lower jaw you can find external diameter. You can find thickness with an accuracy, with a precision which is greater than what you do the things with a meter scale. So this is the diagram of Vernier calipers. So let me now do the things. Let me first of all find the least count of a Vernier scale. Suppose you have you know that you have a meter scale in main body. Here you have main body and a meter scale, and here you have Vernier scale. In downward position, you can see in downward position here you have Vernier scale. So in downward position, here you have Vernier scale and here you have main scale. Now you will find that you know that in main scale you have 10 small divisions in between two divisions. In one main division you have 10 small divisions. So you will find that in 9 main scale division you have 10 Vernier scale division. I have magnified this Vernier scale from here to this point. I have magnified, and you will find that 9 main scale division is equal to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 Vernier scale division. So from here you can write that 10 Vernier scale division is equal to 9 main scale division. You have just seen that 9 main scale division is equal to 10 Vernier scale division. Therefore, 1 Vernier scale division is equal to 9 by 10 main scale division, and it is equal to 0.9 main scale division. Now, least count means smallest measurement by a Vernier scale is equal to 1 main scale division minus 1 Vernier scale division, and this is equal to 1 main scale division is equal to 1 mm minus 0.9 main scale division is equal to 0.9 mm. Okay, so subtract 0.9 mm, and this is equal to your 0.1 mm. So the least count, the least measurement, the smallest value that we can measure using a Vernier calipers is 0.1 millimeter. So let us do some measurement. Here we have a Vernier calipers, and I have put one object in between the two lower jaws. So firstly, here you can see in this figure, here you can see the 0 of main scale is just opposite to 0 of Vernier scale. Both the 0 jars are alongside. So now what happens when you put any object inside any Vernier scale? The zeros are displaced. Here the 0 of main scale is remain at this position, but 0 of Vernier scale is moved to some other position. Now what value we can directly measure from here is, it is your 1 centimeter. After 1 centimeter, two small divisions you can directly measure. 1.2 you can measure, but the length of the device falls up to this distance, this value we cannot measure. So there is one trick. Suppose from up to here you can directly measure 1.2 centimeter, you can directly measure, but you cannot measure this small length, this extra length. So let me show you how can we measure this extra length. So what is the total number of main scale division? 1, 2, 3, 4. So 4 main scale division. If you subtract 1, 2, 3, 4 from below, and it is Vernier scale division, so 4 Vernier scale division. If you subtract this length by this length, then you can get this length. So this is equal to 4 into main scale division, 1 main scale division minus 1 Vernier scale division, and this is your least count. As I have written, one least count is 1 main scale division minus 1 Vernier scale division. So you can write 4 into least count. And what is this for? We have obtained where the two upper graduation mark and lower graduation mark are exactly matching each other, are exactly opposite each other. We know that we have 10 graduation marks in Vernier scale. We have 10 graduation marks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, but this fifth one is exactly matching. You can see fifth one is exactly matching. So how many number of divisions, not number of divisions, number of separations? 1, 2, 3, 4. What is this? Total number of divisions minus 1. here number of division is 1, 2, 3, 4, 5. And when you subtract, when you count only the house is here 4. So what is 4? 4 is here vernier scale reading. What is 4? 4 is here vernier scale reading into least count is equal to, okay, so this much plus this you are reading directly from meter scale, and plus extra thing you cannot measure, so you use the help of you take the help of vernier scale. Okay, so 1.2 centimeter you are already measuring, and plus this extra length. So what is total length, total measurement is equal to, this is main scale reading plus least count into vernier scale reading. So this is how you will be measuring the length of anything. So in this case, let me find the value. So it is equal to 1.2 centimeter plus, it is 4 vernier scale divisions into least count is equal to 0.1 millimeter, and this is equal to 1.2 centimeter plus 4 into 0.01 centimeter, and this is equal to 1.24 centimeter. So accuracy is increased. If you would measure with the help of meter scale, you would measure only 1.2 centimeter using meter scale. And using your Vernier Callipers, you measured 1.24 centimeter up to 100th of decimal point. So what will be error here? We know that in every measurement we have some error. So up to last digit, because last digit is doubtful digit. So for that you can add 0.1, and for that you can subtract 0.1. And this is your this much centimeter measurement. This is the measurement. But in measurement using Vernier Callipers, you have measurement 1.24, and doubt is to the last which is least significant and doubtful digit, and that is equal to 0.01 plus minus 0.01 centimeter. So here number of significant figures is increased, so you can say that Vernier Callipers has given result which is more accurate and more precise.